My name is Piotr Solnica. I am a software engineer from Poland. I live in Krakow, raised and born. And since I'm a software engineer, I obviously have an account on GitHub. You can follow me on Twitter, and you can check out my website, solnic.codes, if you want to learn more about my stuff. And oh man, I am so excited to be here. This is my first time here, and I'm speaking in Cape Town. It is absolutely amazing. It took me 25 hours to get here, and it's almost the same time zone, which is just perfect because typically I would be like jet lagged and messed up and everything, but I'm not, so it's awesome. So thanks for having me here. It's a great honor, really. So I work for a company called CitrusByte. I'm a solutions architect. We're a consultancy from the US. We're most remote. Most people work remotely from pretty much anywhere. We are hiring, so if you're looking for a new job or if you're just open to new positions, ping me. I also work a lot on open source. I'm mostly working on two projects. One's called RomRB. It's the thing on your left, and Dry-RB. So RomRB is a data mapping and persistence toolkit for Ruby. And Dry-RB is like a collection of libraries written in Ruby. Each library solving a specific problem, and libraries are written in a way that you can compose them together. And they are also written in a way that you can just add them to your existing project, and they shouldn't mess anything up. So I'm part of the core team in both projects, so there's a lot of work. If you're looking for some open source project to work on, also ping me, because these are pretty exciting projects to be involved with. So this is my keynote. You don't want to miss this. Yeah, it's the title of my talk. You don't want to miss this. It was obviously a placeholder, but I figured it's a great title. So yeah, it's the title. You don't want to miss this, and you're going to see why. These are exciting times, really, when it comes to Ruby. I think that we reached a point where we're going to see like a new phase in the evolution of Ruby, because for many years, people would typically criticize Ruby for its performance, right? We like to say that Ruby is great for our happiness, that we love the syntax. We love the community, obviously. We're absolutely amazing. But many people criticize Ruby because it's too slow. So many people leave Ruby because it's too slow for them. And these are exciting times because finally people want to address that. So for instance, excuse me, when it comes to MRI, last year we see that JIT was introduced in 2.6. This was a pretty big milestone because it's not a simple thing to introduce in a language. And even though it's still work in progress because it's supposed to make Ruby faster, but didn't. But it's gonna make Ruby faster, so that's great. You can see there's a link down below, which you will be able to click when I publish the slides, where the author of JIT in Ruby explains the plans for the future, so go check it out. And there's also great plan for Ruby 3.0, which is supposed to be 3 times faster than before. But honestly, if it's going to turn out that it's just 2 times faster, it's going to be great too. I actually already noticed that there is a big difference between 2.5 and 2.6, so we can already observe some nice performance improvements. The last thing that I'm personally really excited about are recent additions to the language. For instance, there's a proc composition operator, which was recently added. It's not released yet, but it's there. And I'm so happy to see this because I actually wrote a library called transproc, which introduced exactly the same operator. I mean, not in the proc class, but in a custom class. But this is the same concept. If you ever used Elixir or Clojure, you're probably familiar with like composing functions into like a pipeline where values are being passed from the left to the right. So it's the same thing, like pipe operator in Elixir. So now we're going to have it in Ruby, defined on the proc class. Personally, I would like to see way more functional features in Ruby, but this is a great start. Now, another thing I wanted to mention is TruffleRuby. Are you familiar with the project? Have you heard about Truffle? Yeah? Yeah, so it's not super popular yet because it's not production ready. It's still, right now it's 1.0 release candidate, so they are getting there. It's a really interesting implementation of the Ruby language, which is actually sponsored by Oracle. And there are three really interesting things about this project. The first one is it's going to address, it already addresses to some extent the performance issue in Ruby, but they took a different approach. They realized that Ruby is slow in places like metaprogramming, right? So when we write idiomatic Ruby code, which is highly dynamic, it's going to be slow and it's not optimized at all. So they decided let's do something about that because this is what we do. This is how we write Ruby, especially in libraries. Metaprogramming is very common, and if they can optimize that, they will make Ruby much faster. Another thing is that it's built on top of GraalVM, which is a pretty mind-blowing project. It's basically like a virtual machine for any language, and Ruby is just one of the languages that is supported. You can also run like Python or Clojure or pretty much any JVM-based language. So Truffle is based on Graal, which gives you a lot of interesting opportunities. And another thing, kind of like in JRuby, in Truffle, you can benefit from concurrency, which is something I will show you at the end of this talk. So basically, this is a really interesting project that can solve many problems, and personally, I'm really looking forward to its first production-ready release. Now, another thing that I want to mention is that Rails has matured, and I'm kind of looking at this from a different perspective because I'm no longer using Rails, and I'm so happy that it's matured because we kind of stopped talking about Rails in the sense that for some time that there was like a very long discussion where people would say, okay, I'm using Rails, but I don't like it, so I would like it to change. And people were criticizing Rails for what it is or for what it's not, and discussing what should be added, what should be changed, what should be improved. And this like lasted for years, and it was really exhausting, at least from my point of view. And I think that we kind of stopped because Rails is matured, and it's like a clear signal from the core team. Even DHH wrote an article some time ago where he basically said, okay, this is it, right? Like, that's Rails, it's not going to change. We're done here, right? So this is good news because we can move on. Like people who wanted to have something better, something that will work better for them, can finally move on because, well, we know that Rails is not going to change much. Now, Rails is actually still growing in terms of usage. This is from a website called bestgems.org. It's actually a pretty cool website. So as you can see, Rails is still growing. So it's still being adopted, and it's actually good news. Now, at the same time, there are so many new libraries that are really thriving these days. And I'm especially happy about that because I worked very hard on some of these libraries. I'm going to show you just a couple of examples also from Best Ruby Gems. For example, Hanami. We're going to have a talk about Hanami, by the way. So Hanami is a project that is actually trying to compete with Rails, which you got to say it's an ambitious goal, right? So it's a framework, a web framework, and it's been evolving pretty fast, and its usage is growing, right? It's not a popular project, obviously. It's got like a little over 100,000 downloads. That's not much, but it's growing. The community is growing. The development is speeding up. So that's really good news. Have you heard about Rada? It's another web framework which is actually production ready and stable. It's an interesting web framework that is based on the idea of routing tree. So basically, you define your routes as a tree, and you handle your requests in the same routing tree. So you're like not defining routes in one place and defining logic to handle routes in another place. It's all in a single place, and it's extremely fast. The route resolving is just absolutely amazingly fast. It's an interesting project, and if you've never used it, go check it out. And it's also, as you can see, like it's growing like exponentially. Rome, yes, my baby. Ruby Object Mapper. It's an alternative way of using databases in Ruby, which is completely different than Active Record, and it's also growing. And it's actually blowing my mind that it's just keep growing. That's absolutely amazing. Dry Types is another interesting project from Dry-RB organization, a library that provides all kinds of type objects that you can apply to values. It's used as a foundation for ROM. It's used as a foundation for dry validation. And it's got over 4 million downloads. That's pretty amazing. And this is my favorite example, dry monads. Have you ever used monads in Ruby? Anyone? Yeah, a few people. So it's kind of exotic in Ruby. And I wasn't actually sure if it's gonna become a thing, but it has become a thing. And something happened in October 2018. Like, do you see this spike? For some reason, I don't know what happened, but people actually started adopting monads in Ruby. Dry monads is actually one of many gems that implement monads. So if you're interested, go Google. You will find many Ruby gems. Shrine. Last but not least, it's a file uploader, actually written by a guy from a company. So you might be thinking, why do we need another file uploader? Well, it turned out that we actually need another file uploader, and this one works really well. And it's one of the modern libraries, and it's growing really fast. Now, something that happened last year was that these three communities, Hanami, Rome, and Dry, decided to work together. I'm part of this effort. And basically what we want to do is help Hanami people build 2.0, version 2.0, Hanami 2.0, and then just continue helping with further development. So what we're doing is basically integrating certain libraries, both from Rome and Dry, into Hanami and building entire stack on top of simpler, smaller libraries. And this is actually huge news because, as I said, Hanami is trying to compete with Rails, which is really hard, and we need many people to help. So the fact that we managed to just come together and decided to work together is actually really exciting. Hanami is already at 2.0 alpha. It's obviously not production ready. It's like a technology preview, but it's there. So that's good. Now, I showed you a couple of examples with modern libraries. I like to say that they are modern because they are really different from what people are typically used to when it comes to Ruby, at least. It's kind of funny because when I started working on some of these libraries, many years ago actually, I just kept hearing feedback like, well, this is weird, like, this is not idiomatic Ruby, like, why would you do that? This looks odd. I don't understand it. Yeah, like a lot of criticism, a lot of like just negative feedback. And I actually think that over time we can redefine what idiomatic means. I mean, if you look at Ruby code from the 90s, you will be terrified. I can guarantee you that. It's absolutely weird because it changed so much over time, right? So we just redefined it. And this is what's happening all the time. We're like introducing new patterns, new techniques, and the language, even though it's still the same language, but the way we write it, it's changing all the time. I'm gonna show you a really nice example of this. Have you ever heard about module builder pattern? Anyone? No? Because I'm curious, can you raise your hand if you've heard about it? One person. But yeah, we've got a name for it now. It's called module builder pattern. Now, this is it. So in Ruby, you can include a module, right? And you typically reference a module using a constant, right? A module is a constant, right? So you say include foo, and foo gets included. But what we're doing here is that we're building a module instance that is like configured for this specific class. In this case, we're including an equalizer module, which will define equality methods based on the list of these arguments, like ID, name, and email. So under the hood, we're actually subclassing module class. Yes, you can do that. And then we're creating an instance of this class, and this instance gets included. So it's like a dedicated module for this specific class. It's a very powerful technique. However, it's probably only for library code. I've never used it in application code. But the funny thing about it is that, well, at least I started using it in 2011, right? Now, in 2011, I could see this type of reactions, like, this is stupid, I don't understand how it works, it's going to be hard to debug, I prefer X as equalize or something, right? Like, I would see reactions like that all the time. Now, fast forward to 2018, last year, and this is the type of reactions that I can see now. Like, yeah, this is cool, it's such a powerful technique that needs so little code to achieve so much. These are obviously fake quotes, by the way. But yeah, but this is what we see these days. And the module builder pattern is something that was named like that last year, or in 2017, I don't remember exactly. So there was this guy who discovered this technique through actually looking into some libraries, or he found my blog post from 2011, I think. And he decided to like really look into it, understand it, and explain it. So this is what he did, and he called it, okay, we're building a module, so it's a module builder pattern. Right? He then gave a talk about it, and it's become a thing, right? So it took like years to get there, right? And people are no longer that surprised when they see it. And I'm pretty sure that many people would say, yeah, this is a module builder pattern. Yeah, that's what we do in Ruby, right? But in 2011, that was just weird, okay? Now, there's a lot more stuff when it comes to modern Ruby libraries. So I'm just going to mention quickly a bunch of things that I noticed. So many of the libraries that were created recently, they avoid mutable state, right? So they create objects that don't change. There's no reason for them to be changed. And we also don't monkey patch, so it's much more predictable when you're working with a library that doesn't change every single class or module in your runtime, right? There's also type safety that was introduced by some of the libraries, like Dry-validation that I wrote. This is also an interesting and modern way of writing Ruby code, because you're actually thinking about type safety. And I'm not necessarily talking about things like, type safety in statically typed languages. I'm talking about type safety when it comes to untrusted input, like parameters sent from a web form, for example. Like, we want to check that it's safe to work with it, right? So type safety is also important in dynamic languages. And this is what some of the modern libraries are introducing, right? Another interesting thing is that people started relying on data structures more. There's this really great talk from Gary Bernhardt from a few years ago where he explains how you can use data structures as the boundaries in your application. And I think many people started actually applying this in practice, and it works very well. Which gets us to the last point, functional data processing. This is a pretty straightforward technique where you're basically thinking about your entire program, entire application as like a series of transformations. So you get data in and you get data out, and that's it. And if you're doing this like that, it's so much easier to reason about your code. It's so much easier to change it, and it's so much easier to add new stuff. Now, all these things are just typical traits of these modern Ruby libraries. So I think, at least that's my hope, we're going like more consciously, more functional in Ruby. When I started talking about this years ago, I would also get a lot of negative feedback. People would just keep saying things like Ruby is an object-oriented language. But it's not just object-oriented, right? It has functional features. And I think what we're seeing these days is that people start to realize that, yeah, it's got functional features as well, and we can leverage that. Yeah, so acronyms. Yeah, in software we have a lot of acronyms, right? We have TDD. Are you familiar with TDD? Yeah. BDD, yeah, behavior-driven development. We have RSpec in Ruby, pretty nice BDD library. Domain-driven development is also interesting. There are actually some interesting projects in Ruby, like Eventide, for example, that helps you when it comes to domain-driven development. But have you heard about CDD? It's a thing, I promise you. Yeah. Is it like cat-driven development? Yeah. I'm sure Tenderlove would know something about that. So it's a thing. CDD is a conference-driven development. Yeah. Let me explain. So if you're a software engineer and you also happen to be a speaker, and you're a reasonable person, you want to talk about some code at a conference, right? So you think about interesting things that you know, things that exist, and things that you're confident about, and you like to talk about them. So you send a proposal, and this is what you're going to talk about, right? So you take the code that exists, and you discuss it in your talk, right? If you're less reasonable like me, you're going to come up with ideas that are very exciting for you, and you want to talk about them. It's just that the code has to be written. So you start writing code just before the conference like crazy, just to be able to get there and just show something that works, hoping that it's going to work, by the way. So this is what I've done. I was thinking about, what I would like to show you. Let me think. And I realized, I always wanted to write some concurrent code in some of the libraries and see if I can actually make this work. So long story short, I had to rewrite one library, refactor two libraries, and figure out how to use threads basically in Ruby, and it actually worked. So I'm very happy about that. And there are just two examples that I'm going to show you, but I think it's really exciting. So yeah, quick case study, parallel processing. I talked a little bit about all these modern libraries, and I talked a little bit about the fact that they follow some patterns and some principles from functional programming, like immutability, like using functions, like composing functions, using functional composition rather than some weird object-oriented stuff. ROM and Dry projects follow all these principles and all these patterns. So these libraries theoretically should be easy to change so that some things can be done in parallel. That was my theory, like from almost day one. So I've been thinking about this for like a long time. That okay, when it comes to performance, there's a lot of tricks that you can do in Ruby. But at the end of the day, what I really want to do is to see if I can actually use parallel execution in some places just to get performance improvements. Now, there are two tricks here, caveats, I suppose. In MRI, using threads makes very little sense. But in JRuby and Truffle, you can actually see that parallel processing is faster. So, I mean, it can be faster, right? So I use JRuby and TruffleRuby to see the results. Now, the first example is from ROM. And again, ROM is a data persistence and mapping toolkit. In other words, it means that it's like an alternative to Active Record, right? So we can use this library to connect to your database, fetch some data, make some changes in the database, just do the typical stuff that you do with the databases. So it supports SQL databases, obviously, and it supports associations. If you've ever used Active Record, you're probably familiar with things like has many, belongs to, right? So it's the same thing here. You can define associations. Now, when you're fetching data, associated data, you're using something called eager loading, right? You're probably familiar with that. It means that we want to send as little queries to the database as possible. So, for example, if you're fetching users and their tasks and their posts, whatever, you're going to fetch users and then use this data set to figure out what posts or tasks or any other associated data you want to fetch. So we're going to use at least 2 or 3 queries, right? We're sending, we're using separate queries because it's actually faster than using massive joins. Massive joins are actually slower than using a couple smaller queries. So I thought that, okay, what's happening is that we're going through associations one by one, and we're just saying, give me this, give me that, give me this, give me that, like one by one, right? But in many cases, you can just do this in parallel, right? Like you can just say, okay, fetch all this stuff in parallel, right? Makes sense, makes absolutely perfect sense. And in fact, in theory, I thought, okay, this should be simple in ROM because there's just one place when it happens. So we have this place where we go through nodes, and nodes represent associations, and we just take every node and say, hey node, give me this, give me this, give me this, one by one. And that's what I decided to change. Okay, let's do this in parallel. So I've never done live coding, and today is not the day. But I recorded a video for you, and I like documented the entire process of refactoring so that you can see it live. Okay. Well, forgot about this slide. Yeah. So here's the video. Ready? Okay. I'm typing very fast. Done. Okay. Yeah, that's it. Okay. Yeah, crazy, right? One line. I mean, it's not like I sat down and, yeah, da 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 da, done. It actually took me, I don't remember how many hours, but it took me quite some time to figure out how exactly I want to do it because it is a one-line change. It is. However, I used a gem called parallel because when I used threads manually and started splitting the work manually, it was messy. I mean, it was still a few lines of code, but I wasn't exactly sure how to optimize it because there's like an overhead related to this because you need to like split the work and do it in a smart way so that it doesn't come with too much overhead. I actually made it work pretty good, but parallel jam turned out to be great because it works. Like out of the box, it works and it's fast. So at the end of the day, it turned out to be just this simple change. And obviously, I had to write some benchmarks. And writing benchmarks is really hard. It's really hard. So it also took me a while to figure out how to benchmark it properly. But I made it, and I ran it under JRuby. So under JRuby, here's like the output from benchmark IPS gem. So it turned out that in the single thread mode, it's actually 1.6 times slower, which is a significant improvement, right? And it's obviously just one use case, but I can easily see a lot of use cases where this number would be either smaller or way bigger. Now, I also checked, yeah, this is awesome. I also checked TruffleRuby. And under Truffle, something weird happened because it was slower in multi-threading mode. 2.37 times slower in case of parallel processing. I'm not sure why, but again, Truffle is not stable yet. This is 1.0 RC12. So there's maybe a bug or I don't know. I really don't know. But I made it work under Truffle, which was a success anyway. So this is less awesome. But another example is from Dry-RB. So there's this library called Dry-validation. Have you heard or used Dry-validation before? No? Oh, one person, two people. Okay, three. Awesome. Yeah. So Dry-validation is a project that actually I created in a couple of years ago. This was like my first attempt at solving data validation problem. I've learned a lot. But I also failed like miserably when it comes to implementation details. So the first sort of versions, like I mean, first edition of this library, was kind of messy internally. I made a couple of like design mistakes trying to put too much stuff in a single place. So even though it introduced a lot of pretty cool features where you can validate data, all kinds of data structures in a very efficient way, it was from very early versions, it was extremely fast, much faster than active model validations, for example. So it introduced an interesting concept of validating just data, right? Like we're not validating objects and asking them if they are valid. We're taking data and we're checking if the data is valid. So on top of that, I also added a bunch of really complex features for like custom validations that I called high-level rules. And that was a mistake because it was just too much in a single place, so the library got really bloated, especially that people started using it on a like larger scale and asking me about more features, better performance. So I tried to do that, but it was just impossible to solve all these problems in a single place. So eventually, like I separated the schema validation part into like a separate library, and I wanted to like rewrite dry validation on top of this new project so that I can focus on these high level rules like solely in this library. So I was in Dubai, 7 hours layover, and I rewrote it. Like waiting for my plane, and I rewrote it because I wanted to show it to you. So like 2 days ago, it was actually very simple. So here's an example of how it looks like in a pull request that I opened. You define a contract, and it defines within these params. Within this params block, you can define all the keys and validation for all the values that should be applied. Like the first step that you do, you apply these validations, right? So we define that there's a required email and required age, and there are some optional keys, and there are some basic validations that we're going to perform. And like this is provided by an external library. But like the essence of dry validation 1.0, soon to be released, is going to be these rule blocks. I'm not sure if it's going to be called a rule or something else. It doesn't matter. What matters is that there is a concept of having rules, arbitrary rules that you define. So these rules are executed one by one, right? So we have a list of rules. We take rule after rule, and we say, hey, rule, check this input, and we do it one by one. Now, in this example, it's obviously super simple. We're like checking basic stuff. But like the reason for this library to exist is that you can define anything there. So it's pretty common to have rules that can be heavy in terms of like execution of what they do. They can talk to databases. They can talk to, I don't know, some remote APIs. Basically, they can be slow, right? So I thought, okay, it makes sense to execute it in parallel because they don't depend on each other. There will be a feature where you will be able to define dependencies, like rule A depends on rule B or something like that. But if you don't define it, they don't depend on each other. They can be executed not one by one, but in parallel. So exactly the same thing. Like you have a list of things that you're just calling them or just sending some methods, and it happens one by one. So why not just do it in parallel? Exactly the same thing as with associations in ROM. So another live coding session. So I decided to refactor the code that handles this part where we take every rule and apply this rule to input. Here we go. This will not surprise you that much. Yes, so we're gonna define messages that will include any potential errors. This is our front parallel. Yeah, couple of tweaks. Yeah, done. Okay, yeah, and that was it, right? That was it. So exactly the same process. You have a list of things. You execute them one by one. You change it to be parallelized, and done. It's working. So again, a couple of benchmarks. Under JRuby, it's also faster, so 1.6 times slower in case of single thread mode. And under TruffleRuby, was also faster. So it's like, yes, at least in this case it's faster. And again, I don't know why in this case it's faster, and in the case of Rome and talking to the database and everything, it wasn't faster. But what's interesting is that in this particular benchmark, I will, by the way, I will publish all these benchmarks so you will be able to check them out. But in this specific benchmark, I wrote rules that talk to the database, right? Because I knew that it's going to be slow. So there is a database interaction in this case. And in this case, it is faster. So yeah, it's still a mystery, but I hope it's going to be resolved in final version of Truffle. So why was it so simple? Like, I had a hunch that it's going to be simple. Like, in theory, it should be simple because the code is written in a way that enables you to do this kind of stuff easily. And I'm so happy that I actually verified that it's true. And when you think about it, these are the reasons why it's so simple to achieve. First of all, stateless objects, like no mutation. When I say stateless, I mean that we use objects. They do have state in the sense that they have some instance variables with some stuff, but we don't use data as state, right? So there's no reason to mutate any objects. They are used more like functions. And this is really essential because we have input and we have output. And we compose things together into a pipeline. So it's very easy to introduce parallel execution because you don't have to care about mutable state. Now, separation of concerns is also a really important aspect here, because if you have small blocks that do something, it's much easier to just manage them, to deal with them. And if you want to improve performance in one place and you want to use multiple threads and you have small blocks of functionality, it's obviously so much easier to do because you can have all sorts of issues when you're using threads, right? And composition. When you have small things building up bigger things and bigger things building up entire systems, it's also much easier to introduce parallel execution and just use threads. Like what I showed you in these examples, you have specific objects that take care of very specific things, but they are composed from other objects. So you can like go deeper and discover that, oh, in this case, we can also optimize something. So composition and separation of concerns is also, they just play a key role here. Now, this was basically an experiment for me. I honestly, I had no idea what I was doing. Like, I've been using Ruby since, like, professionally since March 2007. And I've never, ever used threads in production code. Ever. That's crazy, right? And we keep talking about performance in Ruby and how we want to address it. But you can solve so many issues with performance by just using threads. You just need a platform where it makes sense. So right now, unfortunately, it's just JRuby and soon Truffle. But hopefully, we will also see that in MRI, right? So I really want to encourage you to just experiment with this and learn new stuff, because you may discover that, well, Ruby can actually be pretty fast, or fast enough at least. So maybe there's no real reason to move to other languages. I mean, don't get me wrong, I love other languages. I try to learn new languages whenever I can. I love Elixir. I really enjoy using Clojure and Scala. I still dream about learning Haskell, but maybe in another lifetime. But again, like, changing a language without a really good reason is just not a good idea, right? So maybe there's something to learn still, and just apply new techniques to your software and just still use Ruby. There are some things that I would love you to check out, because not just because I work on them, but I think they are interesting. And even if you don't use any of these tools, I'm pretty sure you're gonna discover some new things and learn some stuff. So check out Dry-RB. It's I don't even remember how many gems we have, probably like 20 or something. You should find something interesting there. And check out ROMRB, especially if you're tired of using Active Record and you're looking for an alternative. This is a pretty big project. It was one of those things that like changed completely the way I think about writing applications in Ruby. Because well, using databases is pretty important, and it really does change the way you design your applications, changes the way you think about data structures. So I also encourage you to check it out. And Truffle, oh man, I'm so excited about this project. Check it out. You can actually install it pretty easily, which wasn't the case just a few months ago. It was really difficult. Like I tried to do that over the course of 1 year or so, and I failed like at least 6 times. There was always something broken. But now you can install it using the Ruby version managers like RVM, Ruby install, things like that. So it just works there. They actually have a very, which is something that I've learned recently, they actually have a very ambitious plan. It sounds crazy, but what they want to do is basically take all the gems from Ruby gems, all the gems, and test them with Truffle. Make sure that everything can be run with Truffle. And they want to take the burden of doing so, because it is a burden. Like if you're building a Ruby gem and you need to test it against all these Ruby implementations, it can be a pain in the ass. But what they want to do is just take that burden and do it for you. So that's pretty cool. I don't work for Oracle, by the way. I mentioned that I work for CitrusByte. I just think it's awesome that what they want to do is just make sure that their implementation of Ruby is actually safe to be used with as many gems as possible. They want Truffle to be compatible with MRI. Like we know that there's no like official Ruby spec, but what they want to do is to make sure that it works the same way as MRI, even when it makes no sense. They just want to do it for compatibility reasons. And last but not least, concurrent Ruby. It's a very interesting project that that we use in many places in Dry-RB and ROMRB. It provides a lot of sort of like abstractions that should be helpful when you're writing concurrent code. However, I've tried to use one of these abstractions, and it turned out that using the parallel gem that I showed you is much simpler. But again, check it out. It has some pretty cool abstractions that are very useful. So yeah, that's all I have for today. I'm not sure if we have time for questions. If we do, I'm open to any questions you might have. Otherwise, thank you. It was a pleasure, and I'm looking forward to other talks.